Okay, for today, this is chapter 23, and we're going to be dealing with two samples, and they're independent samples. So, unlike the paired t-test, we're now going to be doing a two sample test for means. So, on the inference sheet that you have, this is the two sample t interval and the two sample t-test. So we're comparing means. We need to combine standard deviations. So you'll notice for the standard error estimate, you have to square the standard deviation, um, add those up, of course, divided by your sample sizes there. So going back to that idea of when you have independent samples, you can't combine standard deviation, but you can combine variance. That's what will be going on there. I do see an issue on my notes right here because the t-test is what we are doing. So our test statistic right here should be a t and not a z. For these two sample t-tests, you're going to be getting the degrees of freedom from the calculator. And when the calculator asks you if you want to be pooled with the data, just say no for this. So when we look at the problems that are given, so you have a blank copy of this and a complete copy of this in your folders. We are going to look at first this sample of resting pulse rates for smokers and non-smokers. So again, those are two independent groups, smokers versus non-smoker. We have 26 smokers, 32 non-smokers, and the means and standard deviations are given for each. So the first thing I did was organize that data right here. Okay. The question asks for, is there evidence of a difference in mean pulse rate? So difference is going to be a not equal to, a two-tailed. And then the last part of the question, when it asks how big is that difference, that means you need to go ahead and do a confidence interval at the end. So the calculator output that you see right here, that's from stat test 4. So when you go to stat test 4, it's going to ask you for the sample means and the sample standard deviations and the sample sizes. It then gives you your t-score, your p-value, and this is where you find your degrees of freedom. So again, you do not need to know how the calculator did that. So the first thing I did was I set up my null hypothesis. I used the subscript of S for smoker and NS for non-smoker. So the null hypothesis is there is no difference in mean pulse rates between smokers and non-smokers. Please make sure that you write there's no difference in mean pulse rates. Don't just write in pulse rates because we're looking for a difference of means. My alternative hypothesis is smokers versus non-smokers for the means are not equal to 0. So this is a two-tailed test. The context of that, there is a difference in mean pulse rates between smokers and non-smokers. So moving on to the conditions here in green. Again, just like the proportions, you need to know that your two groups are independent, and we can consider smokers and non-smokers independent groups when we're looking at pulse rates. Within the groups, you also need to have independence. It told us in the problem they were randomly chosen, and both sample sizes, the 26 and the 32, are less than 10% of the population. So if people are randomly chosen, you need to also attach that 10% condition as well. If a treatment, so an experiment, were randomized, the randomization is all you need to do. You don't need to do the 10%. We are also told that both histograms are unimodal and symmetric. So we just say that that is stated. We do not need to make those histograms. Next, name the test. Conditions are met to perform a differences of means t-test at 55.95 degrees of freedom. You'll notice in the next problem, I make that statement a little bit differently, but you need to make clear that you're doing a difference of means, two independent means. So unlike the paired t-test, now you have a mean for each group. the mechanics here in orange, the t-test, we're going to do the smokers mean minus the non-smokers, that's the 80 minus 74, minus the null, which was 0. And then the standard error, we're going to take our standard deviation from the first group, that was 5 squared, divided by the sample size. So we have to go back to variance. We're going to add to that our standard deviation back to variance. So 6 squared divided by sample size 2. The calculator did all that work and gives you a t-score right here. So just like z-scores, when you get beyond 3, for t's, you're definitely going to have something unusual. So what I wrote in order to show the mechanics, the probability that t is greater than 4.15, I chose greater than right here because my t-score is positive. If it were negative, I would have put less than. Now, since it's two-tailed, that's why we're going to write times 2. The p-value from the calculator was 1.13 times 10 to the negative 4. And that is equivalent approximately to 0.000113. So my conclusion is, with a p-value so low, we reject the null. There is evidence of a difference in mean pulse rate between smokers and non-smokers. So again, the context is really important. It's a mean pulse rate between the two groups, and make sure you mention the groups in context. And then how big is that difference? I went to stat test 0, that's a 2 sample t interval. I did a 95% confidence interval. So a 95% confidence interval estimates the true mean difference, again, the context, to be between 3.1 and 8.9 beats per minute. So that's how you would do it if you're given these statistics. If we're given the data, that's the next problem you see here, where we're going to compare the saturated fat content for pizza sold by 2 national chains. The question again is there a difference? So I know I'm going to be looking at a two-tailed not equal to. The first thing I did was put the information in the calculator. So brand D was L1 and brand PJ is L2. I noted that I had 20 in one group and 15 in another. So I just want to scroll down and show you down here at the bottom is where you can see the calculator work. And I also made histograms for each. So brand D is the blue and brand PJ is the red. So those we'll need to use later on. So first thing I did after that was I did my null hypothesis, and again using subscripts of D and PJ. So the mean minus the mean is 0. There's no difference in mean saturated fat content between brands, and the alternative was a not equal to, two-tailed. So there is a difference in mean saturated fat content between brands. Now, please make sure, once again, that you guys are using mean saturated fat content. This is the communication part that you need to be clear on. So when you're taking the AP test, do not save words. Go ahead and put as many words in as you can so that your context is clear to your reader. For this one, the 2 brands, again, can be considered independent. So that's the independent groups. Within groups, we need independence as well, and that's that we have things randomly chosen and less than 10% of the population, or if it's a treatment, the treatments have been randomized. Now, we are not told they're random, so I stated that. Samples are not random, but can be considered representative of the brand. And histograms for these ones are both unimodal. Brand PJ does have a bit of a skew, but there are no outliers, so we should be okay with this. So I said, assuming conditions are met, we will perform a 2 sample t-test at 32.82 degrees of freedom. Again, that 32.82 was taken from the calculator output down on the bottom left there. And then I went ahead and showed my mechanics. So the t-score, and I'm going to add something here. This should say for this one, t-score 32.82. So I probably forgot that up at the top as well. If you're looking at, yep, this problem right here, we should have a 55.95 written as a subscript for that t-score. So going back down, I took my brand D mean was 11.25. My brand PJ mean was 6.4. That's grams of saturated fat, minus the null of 0. All of that divided by the standard error. So remember, you're going to have the formulas in front of you. Make sure you're doing the standard deviation squared over the sample size, add them together, then take a square root. Because remember, that concept is independent random variables need to be back to variance before you can combine them. So all of that gave me a t-score of 4.99, so almost 5. Again, I wrote this as a greater than because my t-score is positive. If it were negative, I would have written a less than. The two-tailed is 2 times. I didn't draw it out because we're not going to see shading on this one at all. Because essentially we have a p-value of 0. And our conclusion will be, with a p-value of essentially 0, we reject the null. There is strong evidence of a difference in mean saturated fat content between brand D and brand PJ. Now, if we were to draw these things out, just remember, we're going to have them centered at the null, and our null is 0. So we would have ended up way, 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 way out here for 4.99 and shading to the right. And it's going to be mirrored over here by a negative 4.99. So we really wouldn't have seen any shading out there on our graph. It would have just been empty. So that does it for a sample of 2 independent means.